Assalamualaikum and greetings to Madam. Today we will present the topic that we have chosen, which is nuclear fission has a sustainable energy source. First, let me introduce the member of this group and starting with me. My name is Nurul Atika and my number metric is 2022-859-744.
My name is Hasha Farahia binti Wasli and my student ID is 2022480324.
And my name is Rowena Janjusri, student ID 2022826198.
And I am Nur Mashita binti Maila.
Before we going through on this topic, let me brief a little bit about the topic that we have chosen. Nuclear fusion is a process where atomic nuclei combine to form a heavier nucleus, releasing the tremendous amount of energy. It's the same process that power of the sun and stars. Has a sustainable energy source, fusion offers several key advantages. There are four key advantages that I have been found. First is abundant fuels, which is fusion primarily use isotopes of hydrogen, which are plentiful in seawater and lithium, ensuring a nearly limitless supply. Second is clean energy. Fusion does not produce greenhouse gases or long-life radioactive waste like nuclear fission, make it an environmentally friendly option. The third is safety. Unlike nuclear fission, fusion reaction can be controlled easily with no risk of catastrophic accidents or meltdown. And the last one is efficiency. Fusion reaction release more energy per unit mass than any other known energy source, making it highly efficient. However, challenges remain in achieving sustained fusion reaction at a scale and cost-effective level for power generation. Overcoming this hurdles requires substantial investment in research and development, but the potential payoff in clean, abundant energy, making fusion a promising solution for the world's future energy. The reason why we choose this topic and it's relevant to modern physics is, yes, nuclear fission has a sustainable energy source is highly relevant to modern physics. That is because there are four reasons that why it's relevant to modern physics. First is fundamental understanding. Fusion processes rely on our understanding of fundamental physics principles such as plasma physics, nuclear reaction, and electromagnetic force. Advancing our knowledge in these areas contributes to both fusion research and broader scientific understanding. Second is cutting-edge technology. Developing practical fusion reactor require pushing the boundaries of technology in areas like superconducting magnets, plasma confinement, and material science. These technological advancements often drive process in other fields as well. The third is energy innovation. Has a potential solution to climate change and energy security. Fusion embodies the innovative spirit of modern physics. Its development pushes the boundaries of what is possible, inspiring new generation of scientists and engineers to tackle grand challenge. And the last one is global collaboration. Fusion research is a global endeavor with major projects like ITER, and the full form is International Thermonuclear Experimental Reactor, bringing together scientists and researchers from around the world. This collaborative effort mirrors the international nature of modern physics research, with breakthrough often require cooperation across borders. So, in summary, Nuclear fusion as a sustainable energy source is not only relevant but also integral to modern physics due to its reliance and fundamental principle, technological innovation, interdisciplinary collaboration, and potential to address pressing global challenges.
Just that we face when researching. During our research, me and my partners have faces some difficulties such as complex applications, same points, and complex concepts. So, in order to overcome these problems, each of us expanded our resources so we can understand these topics better. Intellectual proficiency in presenting modern physics laws, concepts, and theory. In this slide, I will be explaining about the concept of nuclear fusion and the importance of nuclear fusion as sustainable energy sources. First is the concept. Nuclear fusion happens when two or more nuclei combine with each other, producing another nuclei while releasing a big amount of energy at the same time. As we can see in this example, nuclei D and T combine with each other, causing a fusion, and then it produces helium, energy, and neutron. Next, let's move to the next topic, which is the importance of nuclear fusion as sustainable energy sources. First, nuclear fusion is actually can be labeled as environmentally friendly. This is because nuclear fusion does not emit carbon dioxide and greenhouse gases. Thus, it is labeled as green or clean energy. Next, nuclear fusion releases lesser long-lived nuclear waste than nuclear fission. And last but not least, is nuclear fusion has inherent safety features. Actual details about nuclear fusion. Nuclear fusion provides 4 times more energy than nuclear fission. This is actually nearly 4 million times more energy than burning oil or coal. Next is nuclear fusion is a conventional renewable energy sources. Another interesting fact is nuclear fusion offers a potential long-term energy source that is abundant fuel. Examples of nuclear fusion. First, let's begin with sun. Nuclear fusion actually happens naturally among the stars. Thus, the sun, which is in our atmosphere, is one of the biggest examples. Next is nuclear weapon. Nuclear fusion have higher destructive power and greater efficiencies than bomb atoms. That's why nuclear fusion is used in nuclear weapons. For example, hydrogen bombs. Next is electricity generation.
For my first part, I'm going to illustrate how this concept is applicable in daily life. First, homes, reliable, cheap, emission-free. Second, transport, powers electric vehicle, public transit. Third, industry, supports manufacturing desalination. 4. Agriculture, efficient irrigation, food production. 5. Health, stable power, medical isotopes. 6. Technology, data centers, research. 7. Environment, reduces pollution, conserves resources. 8. Economy, jobs, energy independence. For my second part, I'm going to discuss any recent advancement or controversies associated with the topic. For advancements, breakthroughs. First, NIF 2022 achieved net energy gain. Second, ITER, advancing towards large-scale fusion. Innovations. First, tokamaks or stellarators, stable plasma achieved. Second, HTS, enhanced confinement. For controversies, challenges. First, technical, sustaining reaction, scaling energy output. Second, economic, high cost funding debates. Third, safety, radioactive waste, public perception. For my third part, I'm going to identify potential careers related to the chosen topic in modern physics. First, computational physicists, model fusion processes. Second, material scientists, develop fusion-resistant materials. Third, nuclear engineer, design fusion reactors. 4. Plasma physicists, study plasma for fusion. 5. Research scientists, improve fusion theories. 6. Educator or communicator, teach fusion science. 7. Program manager, coordinate fusion projects. 8. Startup entrepreneur, commercialize fusion tech. 9. Policy analyst, shape fusion energy policies. 10. Fusion technologies, build fusion infrastructure.
Next, propose and plan specific skills needed to excel in the chosen career path. Firstly, we need to have a technical skills including advanced mathematics, computational physics, and experimental technique. Other than that, we also need to master in analytical skills. These skills including critical thinking and problem solving and data analysis and interpretation. Next is soft skills, which include communication, collaboration, and teamwork. Lastly, we need to have a professional development. These skills is including the networking and lifelong learning. We also highlighted the significance of continuous self-development in achieving success in chosen field. The first significance is rapid advancement that evolving knowledge and technological integration. Next, competitive edge in which professional growth, innovational and creativity included. Personal fulfillment is also one of the significant that says about intellectual satisfaction and career longevity. And lastly, the practical steps for continuous self-development, which include regular reading, online courses, and workshops. Next topic is the challenges and strategies one might face in pursuing a career in modern physics. The challenges are including complex and abstract concepts, isolation and collaboration, ethical and societal implication, and physical and mental health. As for the strategies, one might setting clear goals, engaging in public outreach, utilizing online resources, and building a strong professional profile. So, in conclusion, nuclear fusion holds great promise as a sustainable energy source due to its potential to produce vast amounts of energy with minimal environmental impact. Unlike nuclear fission, fusion generates less radioactive waste and carries a lower risk of accidents. It relies on abundant fuel sources like hydrogen isotopes, making it a long-term solution for meeting global energy demands. However, significant technological and economic challenges remain before fusion can become a practical and widely used energy source. Continued research and development are essential to overcome these hurdles and realize the full potential of nuclear fusion for sustainable energy.